it's going to record everything
Okay,
you do.
so hello everyone. My name
And
is
when you're
Wonderson,
done,
and
Just hit the pause button down at the bottom.
okay,
And that'll give you your options for what to do with it.
okay. So, okay, hello everyone. My name is Wonderson. I'm going to start to discuss a little bit about different types of chemical reaction. We start with a single chemical reaction, which is called a combination reaction. A combination reaction is, let's say you have, hold on. Let's say you have a reaction A plus B gives you C. This is called a combination reaction, which means that if you have an element magnesium, which is a metallic element, react with oxygen, gives you magnesium oxide. That's a single replacement reaction. Or another single replacement reaction, which is a common reaction, everybody knows it. It is a household product, and we can say sodium as a metal react with chlorine, which is a gas, and if these two react with sodium chloride, which is a solid, this is also a combination reaction. Remember that all reactions have to be balanced, so when we balance a chemical equation, we always use a coefficient here. So we use 2 here in front of NaCl to balance chlorine, because we have 2 chlorine on the reactant side. So I'm going to use another 2 here, so that that's chlorine, it gives you 2 sodium chloride. By the way, this part is called reactant. We call them reactants, and this is called the products. And remember that in any chemical reactions, the reactants and the products should be balanced. So this is about a single chemical reaction. Like this is I put Roman numeral 1, and then the next one will be Roman numeral 2, which is called a single replacement reaction. What it means is, in a single replacement reaction, it is a reaction between a single element and a compound. So I'm going to say, hypothetically, A plus BC gives you AC plus B. What it means is, let's say I'm going to use zinc, which is a metal, react with hydrochloric acid, which is an aqueous, and it gives you zinc chloride, which is aqueous plus hydrogen. This can be a good example of single replacement reaction. Again, like I said, the equation has always to be balanced. So we have 2 chlorine and 2 hydrogen. So I'm going to put another 2 here, so that way we can show a single replacement reaction here. And the third type of reaction is going to be a double replacement reaction. I'm going to write down a double replacement. Sometimes in some literature you might see a metathesis reaction. Basically, this is a reaction between 2 compounds. Let's say we have AB plus CD gives you AC plus BD, right? Acid-base reaction can be a good example of a double replacement reaction. We have HCl react with NaOH, gives you NaCl, which is sodium chloride, and water. In some cases, this reaction is also called a neutralization reaction. So I'm going to stop the recording now, and then we're going to continue from here. Thank you very much for watching, and I'll get back soon.
Hit record, select all, and hit the delete key.
So another example about
What's that?
No. Here, I just want to I can't put the pen here.
Oh, you hit the
See, I would like to write the pen.
Yeah, sorry. Hit this one there to select the brush. Just hit right on the brush. You don't have to do the drop down. You just right on the top button.
Yeah, when you raise the top button, you still have this.
No. So see, click the top part of that. Move the pen.
Okay.
No, this that part. Click right on the brush. Now go down. So see how it's highlighted?
Right.
No, but go down here.
Okay.
So now, and that's the icon you want to be to
Okay. Okay.
Because the selection and that have like different icons.
Okay.
So now you're back
Oh,
right
it's
in.
recording now, right?
Yeah, it is.
Oh, okay. I'm just writing something and then
No,
I'm
no,
able
you
to
can-
put that. Okay.
Yeah, it's practice.
Yeah.
It's a little weird to wrap your brain around it because you're doing like two oddball pieces of
At the same time,
because the Wacom tablet itself is a little weird to get a hold of because it's not quite a trackpad, but it does work kind of like one with the pen, but still not really.
Right.
And the recording software is a little weird. And that threw me too because I forgot that when I told it to start recording, it was going to show whatever was underneath it, which in case happened to be the scribble that I had already made, and I forgot you have to erase it.
Right. Okay. Let me. All right. Okay. Now, I'm going to say a little bit about this reaction. This is also a double replacement reaction. We have here calcium hydroxide. It's a metallic oxide or a basic solution. It's called calcium hydroxide. And then we have sulfuric acid. If you noticed, I use abbreviation AQ. AQ means aqueous. It's like a French word, aqueous. Aqueous means water diluted or water a water solvent, in other words. And you have calcium sulfate aqueous. Well, actually, if it is just water here, we just say a liter here, it's just pure water. Aqueous means a solution. A solution is basically a solute plus solvents. Okay, this is also another thing that we need to know. Solute is a solid part, and the solvent is the liquid part. This is the minority part, and this is the majority part here. So this is an explanation of the reaction of double replacement reaction, which is calcium hydroxide with react with sulfuric acid. Okay, the other things that we need to also make sure that the equation is balanced here. So you basically have two hydrogen and two hydrogen. You have two hydrogens here, so we basically need to put 2 here. It's going to be 4 hydrogen. Now, as far as concerned with oxygen, we have 2 oxygen here. We have 6 oxygen and we have 6 oxygen, so the equation is balanced. So we can say that the equation is balanced. So when the equation is balanced, you say that the law of conservation of mass is applied. The law of conservation of mass is applied or implemented. And the other type of reaction is a precipitation reaction. I'm going to say precipitation reaction. Maybe we can write precipitation here. Precipitation.
Or say, so you got stuff and you got a whole page of stuff. You don't even have to pause. If you just go up to select all, delete. See, it only takes a couple of seconds.
Okay.
So and then you just keep going. You don't have to even stop.
Okay. Now I go to brush here.
Mm-hmm. And you just take the first one.
Okay.
That's fine. And then you're back to writing.
Okay.
Yeah.
And then now continue to record. Okay, it's recording.
Mm-hmm.
And then once I
in
finish
this
this,
case, I would say if you want to clear the screen, you don't even need to pause it. Just clear the screen and keep going.
but you have to go select all.
Yeah. But that's fine. You don't have to pause to do that.
Ah, okay. Okay.
You can have all these
Okay,
functions.
gotcha.
You don't have to pause to get to those.
Mhm.
It only records in this space, but you can still do things up here.
Mhm.
The students won't see it, and that's fine. They don't need to. They only need to see
Okay.
your writing. So.
Right. Okay. All right. The next point is converting mass to moles and vice versa. All right. So we're going to discuss about how to convert mass to moles and also how to relate moles to the number of molecules. All right. the number of molecules. So there is a principle called Avogadro's principle. I'm going to write what's Avogadro's for you. Avogadro's principle. What Avogadro's have said that if you have 1 mole of substance, all right, 1 mole of a substance, it always has a fixed number of molecules in it. It's going to be 6.02 times 10 to the power of 23 particles in it. This is not a random number. This is a number that is experimentally determined. So if you have 1 mole of water, for example, water may be an easiest example. In 1 mole of water, there are 18 grams of water. So in 18 grams of water, how many molecules of water are there? How many molecules? So you basically, to find out the molecules of water, it says since it's 1 mole in there is 6.02 times 10 to the power of 23 molecules of water. All right. So it's proportional. Say for example, if you have 36 grams of water, you will have 2 moles of water. In 2 moles of water, you will have 6.02 times 10 to the power of 23 molecules, which is times 2, and it gives you about 12.04 times 10 to the power of 23, and it continues like that. So you basically goes like that. So so this is how the number of molecules of an atom are related to each other. So let's say that you have, someone might say, okay, I have 58 grams of sodium chloride, and how many moles are there? What's the number of moles in 58 grams of sodium chloride? Okay, and there will be another question: how many particles, how many formula units are? How many formula units are in 58 grams of NaCl? So one way that you can do this is like 1 mole of sodium chloride is how many grams? Okay, sodium has 23 grams and chlorine has 35.5 grams. So if you add them, it's going to be 58.5 grams. Okay, so we're going to continue this in a minute. So so in 58 grams of sodium chloride, so we basically have since 1 mole is equals to 58.5 grams, so 58 grams of sodium chloride would have how many moles? So we divide 58 grams by 58.5 times 1 mole. So this gives us, if you do the calculation, it might give you, let's see, you just divide 58 grams divided by 58.5, sorry, 58.5, so it would be about 0.99 mole. Alright, and how many molecules are there? Simply what you have to do is 0.99 mole times 6.02 times 10 to the power of 23 divided by 1 mole. So if you multiply, you don't have to worry about this number right here. You just multiply 0.99 to 6.02. So it gives you 0.99 times 6.02, which gives you basically that gives you 0.99, sorry, times 6.02 gives you 5.95 times 10 to the power of 20. So it's a little bit more than less than 6.02 times 10 to the power of molecules. And here is the lecture for today. We'll continue next time. Thank you very much for listening.